Guidelines for a new car-free mega smart city, Master Planning, 2026. Based on an actual 16,492 hectare or 40,752 acre case study for the expansion and modernizing of an existing old city into a new car-free mega smart city. Location confidential. Prepared by MBH International Architects and Urban Designers. All copyright and intellectual property rights reserved by MBH International Poland and MBH Architects South Africa. Part number 1. Synopsis. The metropolis of the future is car-free. We are running out of time. Our cities are in many instances expanding at an exponential rate, and our suburbs are sprawling at an alarming tempo, seemingly without order, planning, or direction, growing uncontrollably like a living organism, having to house more and more people, especially in developing nations, placing ever-increasing demands on our resources and on our infrastructures and ultimately on our environment. And ironically, we think that building more roads and more cars, spending countless unnecessary hours in gridlocked traffic are the solutions. But in reality, providing more accessible, more economical, and more environmentally sympathetic means of public transportation within the inner city, as well as within our suburbs and between our cities, thus linking everything together into a more cohesive metropolitan environment, is in fact the more sustainable solution. Benefits of public transport versus cars. Providing more economical and convenient public transit options within our suburbs and within our inner cities and between our suburbs and our inner cities and between our cities have numerous benefits for our climate, our environment, our infrastructure, our productivity, our health, and our personal safety. An effective public transport network also reduces traffic-induced stress as well as the need for private car ownership. Proven benefits of a car-free metropolis. A car-free city offers several significant advantages and benefits for both individuals and the environment. Here are some of the main benefits. 1. Reduced traffic accidents. Fewer traffic collisions. The absence of cars significantly reduces the risk of accidents, which can result in fewer injuries and fatalities, and reduce stresses on emergency services having to attend to accidents. Safer streets. Statistically, 300,000 pedestrians are killed globally every year. These deaths are completely avoidable as streets become safer for pedestrians, cyclists, and children as the traffic danger decreases. 2. Improved air quality. Less air pollution. Without cars, the emission of harmful gases like CO2, NOx, and particulate matter decreases, leading to cleaner air. Healthier environment. Better air quality reduces the incidence of respiratory and cardiovascular diseases in residents. 3. Enhanced public health. More active lifestyles. People are more likely to walk or cycle in a car-free city, promoting physical activity and reducing health issues like obesity and diabetes. Lower noise pollution. Reduced traffic noise contributes to lower stress levels and improved overall well-being. 4. Sustainability and climate change mitigation. Lower carbon footprint. Without cars, cities have a much smaller carbon footprint, helping to fight climate change. Promotes eco-friendly transportation. In place of cars, sustainable transport options like public transit, bicycles, and walking become more efficient and popular. 5. More green and open spaces. Public spaces for leisure, roads, parking lots, and other car-related infrastructure can be transformed into parks, recreational areas, and green spaces. Biodiversity. More green areas encourage urban wildlife and improve biodiversity in the city. 6. Increased social interaction. Walkable neighborhoods. People are more likely to interact with each other when they walk or bike, fostering a sense of community and social cohesion. Cultural vibrancy. Car-free spaces can host events, markets, and public gatherings, enhancing the city's cultural vibrancy. 7. Economic benefits. Reduced transportation costs. Without the need for cars, individuals can save on fuel, maintenance, and parking fees. Boost to local businesses. Pedestrian-friendly streets often attract shoppers and tourists, benefiting local businesses and the economy. Increased productivity on the commute. Commuters can spend their time working on laptops or reading instead of fighting traffic. Cost savings for cities. Cities can save money by reducing the need for road maintenance and the construction of new infrastructure for cars. In summary, car-free cities can lead to healthier, more sustainable, and more connected communities while addressing environmental challenges and improving the urban experience for all residents. The number one benefit of car-free cities is reduced risks to pedestrians. We do not need fast cars or fast motorcycles with 300 to 600 horsepower V6 and V8 engines to commute within our suburbs or inner cities. Pedestrians are vulnerable and should never have to share a road surface with powerful motorized vehicles traveling at high speeds, and should always be separated from big fast cars and trucks for their own safety. So if the number one benefit of car-free cities is reducing the risks to pedestrians, then what is the number one solution? The number one solution to reducing the risks to pedestrians is removing cars from our cities and suburban neighborhoods. To this end, only battery-powered golf carts or similarly sized vehicles and scooters with speeds governed to a maximum of 35 kilometers per hour or 20 miles per hour should be permitted within our suburbs and inner cities. All larger cars should remain in designated central parking lots at the entrances to all suburbs and the inner city, from where the public transit network can be accessed to commute with further inside the inner city or neighborhoods. If it is not practical to remove cars from our cities or neighborhoods, then what is the number two solution to reducing risks to pedestrians? The number two solution to reducing risks to pedestrians is by separating pedestrians from cars. Examples of pedestrian separation. Example 1. Effective sidewalk integration in residential neighborhoods. Sidewalks are the most effective way of separating pedestrians from vehicles and should be properly demarcated, sufficiently wide, unobstructed, accessible to mobility-impaired persons, and separated from road surfaces, preferably by means of a landscaping barrier in a typical neighborhood scenario. Effective sidewalk integration in the inner city. In the inner city, sidewalks should be raised 1 or 2 levels above street level and should be enclosed and integrated into the street facades of buildings, linking entire city blocks together above street levels, completely separating pedestrians from cars, and also providing a continuous dry and pollution-free walking environment for pedestrians. Effective sidewalk integration when accessing public transport. In a scenario where public transport needs to be accessed by pedestrians on street level, then the outer lanes of the road surface directly adjoining the sidewalks should be reserved for public transport access, and the inner lanes of the road surface should be reserved for cars, so as to avoid pedestrians having to cross into or over the road surface to access public transport. Example 2. Pedestrian bridges. Pedestrians can also be separated from car and tram traffic by means of pedestrian bridges, spanning from sidewalk to sidewalk across road surfaces. However, such bridges will have to be fitted with escalator and/or elevator access to make it easily accessible, especially for disabled pedestrians. A further way of using pedestrian bridges is by directly linking buildings overhead the street traffic. To make these pedestrian bridges more inviting to use, instead of jaywalking, where laws don't exist or are not enforced, the interiors could serve as retail outlets such as for coffee and electronics shops or even restaurants, etc. Example 3. Sidewalk barriers. Since jaywalking is in all probability the biggest cause of pedestrian accidents in areas where cars are permitted, it should be strictly controlled, and one effective way of preventing jaywalking would be by creating see-through barriers between the sidewalk edge and road surfaces, guiding pedestrians to the nearest safe and controlled crossing points. These barriers could be used in conjunction with the previously mentioned examples of pedestrian separation. What then are the alternatives to cars? Metropolis planning overview. Smart and megacity design principles should include the creation of a central inner city, including and surrounded by a calculated and balanced mix of other use zones such as healthcare, residential, commercial and retail, hospitality, industrial, educational, worshiping, and recreational zones, forming the mid and outer cities, all within a walkable and transit-oriented configuration that form pedestrian-friendly and safe urban and suburban environments. Transit-oriented development. All of these various use zones should be interlinked to the inner city by means of parks, cycle lanes, walkways, and a transit-oriented, infrastructural public transportation network, all easily accessible by the entire metropole's population, to decrease the risks to pedestrians and private stresses of time spent in traffic, and to minimize the public-borne expenses of road construction and atmospheric pollution. Integrating all these various use zones that comprise a metropolis into a more sustainable public transit network consisting of combinations of tramways, metros, cableway pods, and drone taxis is in fact the more economically and environmentally sustainable long-term solution, and not more cars and roads. How do we integrate our buildings into a transit-oriented model? Architecture within the smart city of the future. Our buildings within smart and mega cities should be so designed as to be easily and conveniently accessible from and integrated with the public transportation networks. Urban planning principles identifying the various use zone tiers. The various use zones should be allocated to one of the following three tiers. Tier 1, the center of the city, should consist of high-rise mixed-use buildings and skyscrapers to form the inner city, also known as the central business or financial district or downtown. Tier 2, immediately outside and around the inner city, medium-rise mixed-use buildings should form the mid-city. Tier 3, a variety of 7 low-rise mixed-use zones should form the remainder to form the outer city and should include 4. A large residential zone containing a variety of housing typologies. B, a dedicated hospitality zone in close proximity to airport services. C, an industrial zone with easy access to airport freight services. D, a zone dedicated to healthcare-related buildings. E, an educational and academic zone consisting of a new university and other educational institutions. F, a recreational zone incorporating a variety of indoor and outdoor leisure activities. G, commercial strips integrated into all of these Tier 3 zones.